So we lost power. I'm in South Florida, so we lost power a couple of times last night, and then it came back up this morning before it was time to get ready. So it was great. And then about an hour ago, it went out again. And I'm wondering if this isn't just a maintenance outage where they just are having to replace some stuff. But anyway, it's a little bit dark here. I don't have power, but I've got a bunch of backup batteries, so I just turned on my light, so at least you guys can hopefully see me. Ben correctly noted that it looked like I was in a closet before. But anyway,
We refer to that as, the hostage view.
yeah, exactly. Welcome everybody. I hope if there's any other fellow Floridians or Southerners on the call that you also survived the storm. Is there anybody that is new or hasn't been here in a while that would like to introduce themselves or a project that they're working on? Nick just gave us a great tour of his home, which is absolutely amazing in Utah and incredibly energy efficient. Which that was a fun tour, Nick. Thank you for that.
You're welcome.
So Andrew, it's my first time here.
Welcome. Nice to see you, Scott.
Thank you. Yeah, so just a brief intro. My name's Scott Parker, founder and CEO of Traverse Aero. I'm a serial entrepreneur, but mechatronics, mechanical engineer at heart. Been designing drones for about the last 18 years. Companies like Makani, Zipline, Valancy, Mighty Fly. So done a lot of the hands-on work and, been setting up manufacturing in factories and putting planes out there in the world. So, yeah, happy to be here.
Thanks for being here. Great to have you. I'm always looking for interesting presentations, so let's talk offline if and when the time is right to share what you're working on.
Sure.
Anybody else hasn't been here for a while or has a new project that they want to talk about?
Yeah.
Hey, Hugh, good to see you.
Hi, Andy. Glad to hear you're safe. I was wondering if you were had taken refuge up here in the Northeast.
I thought about it.
Yeah. Hello, everybody. My name's Hugh Kelly. I've been running marketing as a consultant for Alakai Technologies for about the last year, so hydrogen powered eVTOL.
Awesome. Very cool stuff. And Hugh, you're in New Hampshire, and I've been spending a lot of time in New Hampshire as well. I just started a new position with Rotor Technologies in Nashua, which is where Hugh's based as well. So we've been able to spend a little time together, which has been great. And so I'm the VP of commercialization for Rotor Technologies, and we're building some really cool heavy lift UAVs that are right now based on the Robinson R44 platform. So the day will come that I'll hopefully do a presentation on that, but I've just been there a couple weeks and haven't put the deck together yet, but I will. Anyway, welcome, Hugh. Great to see you.
Likewise.
Anybody else?
Andrew, maybe I know I've been here a couple of times. I'm somehow on the distribution, and so you mentioned Rotor Technologies. I'm with the FAA. I'm the Deputy Regional Administrator up here in New England. You'll have to tell Hector I said hi.
Will do.
And they are doing some interesting things. And I guess with our aircraft certification group, I'm somewhat privy to some things that are happening and a lot of exciting things from different companies and different new entrants into the trade space. So it's always exciting to see it, and certainly wish all those people success in those future endeavors. I think it's helping us build a more robust, resilient air transportation system that's doing a lot more than what you would have thought 50 years ago. So with that, I'm going to step to the side and listen and hopefully learn.
Well, first of all, thanks for being here, Ken. And you're absolutely right. We've moved from evolutionary phases of aviation to revolutionary. Everything, all forms of the power and the airframe and everything seem to be changing all at once. So it's a super exciting time. And on the topic of Rotor and the Northeast, you are welcome to come on over. We'd love to give you a tour if you haven't seen the facility already. Bring friends. Anyone else? How about events? I think in February we've got the Vertical Flight Society Transformative Vertical Flight event is going to be in Phoenix this time around in February. Is anybody planning to go to that one? I don't know if I'll be there. Any other events that people have gone to or we should have on our radar? That'll be a fun one, I think. I've got some things I wanted to talk about. Yeah, go ahead.
There is
John,
in Utah, I'm gonna attend 47G0 Summit on 24th of October. It's about advanced air mobility and defense.
Cool. That'll be a good one. Take some notes for us.
I will. Thank you. But it's only 1 day.
Pardon me?
It's only 1 day event.
1 day. I was supposed to be at the Elevate UAV conference in Miami yesterday and today, and that unfortunately canceled due to the storm. So I think they postponed that one until November, but that looked pretty interesting. Anyone else before I jump into some discussion about regional air mobility? All right, let's test my sharing skills, which were pretty weak before. Can you see connecting the dots?
Yes.
Okay, great. So I'm going to just jump right in because I got a good bunch of slides here about regional air mobility, and then I want to have a little discussion afterwards. But NASA defines regional air mobility as transportation that is equitable, economical, environmentally friendly, and gives us access to local airports using aircraft with ranges of 50 to 500 miles. We're going to talk about a little background today on regional air mobility, history in the United States, aircraft design, and then what does the market look like in general. So just the background here in the United States is that after World War II, the federal government put a lot of time, energy, effort, and energy into building out airports, about 6,000 of them. And it just created this massive network that still exists today of small regional airports. In 1978, we had the Deregulation Act that removed price and route restrictions, and it really introduced, it created a new situation where there was a lot of fierce competition for what then became a commodity product. And it did, you know, competition did what it was supposed to do. It brought prices down, but it also made things challenging for some of the operators. And at the same time, the federal government had to put in place the Essential Air Service program to prevent the loss of service to lesser used, more remote locations. And so that subsidized what would have become unprofitable routes to ensure those remote communities maintain a connection. So what are the cost drivers behind flying today? We've got, here, I skipped a couple slides, sorry. There we go. I thought that looked a little funny. This is what we're looking at for in terms of airport numbers today. There's about 5,000 public use airports in the United States, about 3,000 FBOs, and yet for most of our flights, we just use about 30 airports. 75% of passenger enplanements and 80% of cargo move through 30 primary airports. So these are some of the cost drivers behind aviation today. Commercial aviation, we've got high fuel costs and high engine costs. And so the way that we kind of mitigate those costs and bring cost per seat mile down is by adding more passengers, which then requires more crew on these larger aircraft, which increases the expenses, and then therefore we need more passengers to smooth out those costs and bring them down per seat. The other thing is turbine engines are expensive, and they take a good amount of maintenance. And so that's another cost driver that pushes airlines towards maximizing passengers and minimizing engines. And the result is we have fewer engines than have been the case in the past. Bigger airframes that are using larger airports, and we have a centralized hub and spokes system today. So we don't see 4-engine aircraft like we used to. The 747s are being phased out. We're moving to 2 and one engine aircraft for efficiency's sake, but that lack of redundancy isn't necessarily a safety feature. So big picture, why don't we have more regional air mobility today? It just comes down to that cost per seat mile. On the smaller aircraft, we're talking about $1 or more per passenger mile, and with the larger aircraft using the hub and spoke system, it's more like 10 to 30 cents a passenger mile. What that's created is a situation where for shorter trips, people are just driving. So in the US, for those up to 500-mile trips, almost 90% of those trips are being done by car, and more than 70% in Europe. And these aircraft are, the fleet size is starting to shrink. So you can see in mid 90s, we kind of peaked out on the number of 19-seat aircraft used for regional air mobility, and it's been shrinking ever since. And if we look at the European market, we can see the number of departures on the left. That's been decreasing over time. Same in the United States. And if we look at upper right in the gray, that's rural and remote flights. We can see that not only are we reducing the number of departures for regional air mobility over time, but the ones that do exist or that are remaining are not necessarily between large city and large city. It's just they're flights out of necessity to get to remote areas. So consequences are that we've got loud polluting aircraft today. Costs are high, both operational and acquisition, and we need those big runways. That's causing us to have the hub and spoke system. And those high costs are getting mitigated by high passenger volume, which continues to support the larger aircraft. Hey, can I have everybody mute?
I apologize.
Catching a little bit of feedback here.
Yeah, that was me. Unfortunately, I lost my internet connection. I'm back on again. I was using my phone user clutch.
Okay.
It should be okay now. Sorry about that.
Okay, awesome. Yep, no worries. All right, here we go. Sorry about that. Okay, so we've seen situations like this in the past where we've got an existing network, but we've got equipment that is large and cumbersome, and that we would like to have smaller and more convenient. And that was in the 80s with the computer revolution. We already had an existing network for communications. Most homes already had a phone line. What we needed was the equipment to get smaller and more user-friendly. And that's where we are today with regional air mobility. If we could bring those costs down, NASA took a look at this. They found that for every 10% in cost reduction that we're able to create through more efficient aircraft, then that could add between 500 and 1,000 city pairs for each 10% in cost reduction, which is a big deal. That's a lot of cities paired up. And they also found that the ideal aircraft size might be about 9 passengers based on current regulations and capabilities of the aircraft. If we look at, this is sort of a regulatory summary in the United States. For an aircraft that has 9 or fewer passengers, they have a lot more capabilities in terms of airports that they can operate in and out of. The single pilot operations are allowed. The pilot in command obviously has to have a good amount of flight experience and a commercial certificate, but less potentially than what would be required with other larger aircraft. And this is talking about range a little bit. The upshot is, for these smaller aircraft without a lavatory, about 1.5 hours is as far as we're going to want to try to take people anyway. And that gives us an idea of what sort of range we want to be thinking about. And we also want to be thinking about there being 45 or 45 minutes or so of reserve range. Here's some of the hassle factors that operators can be thinking about. Trip time is obviously shorter with regional aircraft, and the predictability is good if we know when we're going to be able to get there and and depart and so forth. But the questions are, what are the costs, scheduling flexibility, reliability, and how many times do we have to change in and out of different types of transportation? So the way to make regional air mobility easy to use and unlock the value is to make it efficient and affordable. Electric motors and fixed wings are a great way to do that. We can have meaningful time savings with convenience and flexibility. Rideshare apps, just in the same way that we've moved from having to call a taxi company and hope for the best. We now have more control and are pulling from a wider number of potential service providers. The same can happen in aviation and will. And then societal acceptance is going to be important as we are able to show people the benefits of distributed electric propulsion, the safety, the redundancy, and so forth. That's definitely going to help, as is the quiet. And then the environmental friendliness is going to be another positive, where local people near the airports can start to see and understand that these are quieter aircraft with little or no air pollution. So a little bit about aircraft design. These are some of the regional airliners that are in production, 9 and up to 19 seats. This is what they look like over the years. Ben, I think you know a little bit about the Cessna 208. I think Ben had a big hand in designing that aircraft, which is super cool. When we look at the designs over time, they haven't changed dramatically. Still fixed wing, high wing, 1 or 2 motors, but pretty similar design. Certainly a lot of positive forward iterations that have occurred, but in terms of the overall airframe, it hasn't changed tremendously. So why do we think that could be the case today? Well, we've got a confluence of a lot of different technological capabilities in terms of design, materials, energy storage is changing, our propulsion options are increasing, control automation with fly-by-wire systems, and the ease of use that we talked about with apps. All those things are coming together and can have and will have a big effect on the way that we travel. So we're looking for efficient aircraft with low costs, and that can mean fixed wing is a great way to go, unless we need have applications for vertical takeoff and landing. Fixed wing is just very efficient. With all or some electric propulsion, that gives us a lot of efficiency and allows us to take advantage of distributed electric propulsion, because we need the range that we want of maybe 90 minutes of flying plus another 45 minutes of reserves, another 150 miles. That can mean battery can work well, but hybrid electric can potentially work even better because it gives us more range. And if we look at the car world, I drive the car on the right, the Chevy Volt with a V. It's got a battery plus a generator. The one on the left is all electric, so a battery. My car, the one on the right, I didn't need any special infrastructure, just plugged it into my regular outlet on the wall. Versus an all-electric car, we'd need at least a charger, so it needs a little bit of infrastructure. They weigh about the same, but there's a big difference in the range. And if we think about having to subtract 150 miles for an alternate airport, that's going to bring us to less than 100 usable miles on an all-electric vehicle versus with the gas generator and the battery and my car on the right, I've got a lot more mileage to work with. And therefore, even when I pull out 150 miles for just breathing room, I still got plenty of range left. And that is something that we could potentially, and many companies are applying to the aviation world. So that hybrid electric architecture can work well, given the fact that we need to have reserve range, and we also want to have 90 minutes of flying time to get us between city pairs. So these are some of the positives, and we're using tried and true technology. APUs are not a new thing in aviation. They generate a lot of power. They're smooth, and they can be paired up with batteries to replenish those batteries. And also, when you've got both batteries and an APU, both can be outputting power for takeoff phase of flight when we need the most power. And then over the other easier phases of flight, the APU can be running to replenish the batteries. kind of a cool system. Saves fuel and gives us the ability to have an electric system that then takes advantage of distributed electric propulsion and some of the other advantages of electric motors. When we use electricity, we've got pretty stable costs versus when we look at fuel costs. They're fairly low now, but I'm old enough to remember that has not always been the case, and they can be fairly unpredictable. The other positive to pivoting to electricity is that we've got a lot of pollution fees that are coming down the pipeline, certainly in Europe already, more so on a state-by-state basis in the United States. And it's going to shift the advantage to companies that are building aircraft that are completely or partially electric, because they're going to be more fuel efficient. These are some of the carbon pricing initiatives that are ongoing. There are many more beyond that. And so this is just sort of a summary of when we're able to pivot to electricity, some of the positives that we get from that. Differential thrust gives us great effective control, even at low speeds. Smaller rotors are quieter. We've got better redundancies, and electric motors are extremely fault tolerant and reliable. And then if we think about blown lift architecture, that gives us some new superpowers in terms of being able to take off and land with very short runway distances. So this is one example of a design that's using blown lift, and you can see they've pretty much covered both the wings with rotors. So they're really washing the wing with air, so that even when the aircraft isn't moving, if the propellers are, they're moving air over the wing, and that's creating lift. Even before the aircraft's moving, it can create lift on its own. And that's what gives it its very short runway capabilities. And in the picture below, you see that they're really taking over a vertiport to enable takeoff and landing in an urban environment. Yet they still get the advantage of efficient fixed wing operations. Some advantages of blown lift eSTOL. There's no transition change, so we've got less to worry about, fewer things to break in terms of single points of failure than we would with a transition changing aircraft. Fixed wings are always great when we can use them. They give us the best efficiency, and aircraft with glide ratios make me feel good. All else fails, I can find a nice road and put it down.
I have a question.
Yeah.
These STOLs, do they need a longer runway to land than to take off? That's my common sense.
You know, I think they can create a fairly high amount of lift without forward airspeed because of this architecture. However, the downside is normally that, you know, when we're landing an aircraft at a very low speed, our control surfaces start to get mushy. And if we're doing that in an environment where a precise landing is important, like we're looking at here, that matters. Where an aircraft like this, I think, can mitigate that issue is with the distributed electric propulsion. So even at a low speed, if we need to, you know, pull right or left, we can do that. The flight computers will do that by taking into account our control inputs to a power-by-wire system that will then supply the appropriate amount of power to the rotors that need to pull us left, right, up, or down. And if you can see in an architecture like this, if you needed to nose forward or nose back, you could actually do that with the rotors by changing their speed. So to answer your question, I think we could have a fairly short landing distance as well, without a problematic loss of control due to the slow speeds.
Thank you.
Yeah, the flaps on these aircraft are huge too. If you look upper left, you can really see that that's one of the components of the this eSTOL configuration, is they just have massive flaps. So we talked a little bit about the temperature change. You know, the warmer it gets, the more lift we need to create. As carbon dioxide in the atmosphere is building up, it's just like a blanket or like the glass in our car on a hot day. It's just trapping the heat, and it's been going on for a while due to the emissions we create when we burn fossil fuels. No surprise there. I've had people tell me, oh, well, you know, it always fluctuates. And that's true. It does, but not to this degree, certainly. And this is from NASA's data. And so I agree, carbon dioxide in the atmosphere does fluctuate, but we're the last time there was this much, we were under, I think Florida would have been under the ocean. Hottest years on record. It just is getting hotter every year. We had the hottest day in history of all time in July of this year, as we're cruising through 420 parts per million. And that impacts air travel. Of course, the hotter air makes it more difficult for us to take off. We've got shifting wind patterns. Hurricanes are more likely when the ocean water is warmer. So we're expecting more of those to hit us here in Florida, which will be super fun. And of course, a lot of our major airports are near coastal areas, and seawater threatens those airports. So electrification and having more efficient aircraft are good ways to start to mitigate this. It's making the news, what's going on with climate and aviation, and that means that it's getting people's attention. And the good news is that a lot of investment dollars are moving into electrification and new types of aircraft that are more efficient. And certainly that will be the case with both electrification and regional air mobility. Solar capacity is increasing, and that's great because that's going to make clean electricity less and less expensive. We were at the front of this meeting, we were talking about solar panels on homes. I don't pay for electricity anymore, and many people aren't, and it's a great thing. And that's going to happen in aviation as well, to continue to bring the cost down. Airports happen to be a great place to put solar panels. We've got a lot of space that we don't want occupied by anything taller than a foot or two, and that could mean solar panels. And so then airports can start to become producers of electricity rather than solely producers of emissions. All right, so now we'll finish up just with a quick look at the total market and who are the buyers for these aircraft. According to I think it's a General Aviation, General Aviation Manufacturers Association. There's about 3,500 aircraft that are delivered every year. About 700 business jets, 500 turboprops, 1,500 piston aircraft, and about 1,000 helicopter deliveries. McKinsey took a look at the total addressable market and analyzed that over the next 10 years, between 18,000 and 36,000 regional air mobility aircraft could be absorbed into the market. That's 1,500 to 3,500 aircraft a year. And to give that some context, 1,500 is about the total number that were built in 2008 at the previous production peak. So this is a big change in terms of aircraft production and specifically the way that we will be able to fly. In terms of dollars for services, 75 billion to more than 100 billion. And this could affect 300 to 700 million passengers a year, of which I would like to be one, because we do end up doing a lot of driving trips that I think we'd all rather fly, but it's such a pain that we don't. Companies are investing. This is a graph of sustainable aircraft that are in development. And these are some of the markets for regional air mobility. The ones in italics are potentially public entities, and then the ones below air ambulance. Air ambulance could be public or private, and then the others are private markets. And that is it for today.
Great.
What
Thank you.
questions and discussion points do we have? Ben, you've seen this one before. Did it get any better?
Yeah, no, it was still, I took a lot of notes. So no, it's very information dense. So there's always something in it to catch almost on every slide. So,
Good,
yeah.
good, good.
Yeah. It's an eye opener. I think it's a great pick. One question I have is looking at the economics as we shrink the size of the aircraft, then the salary of the pilot begins to rise in terms of percent of ticket. Is there a crossover point there? I have a feeling that one of the reasons why we don't have VLJs blocking these guys is because we realize we can't pay to have that person drive 2, 3, 4 other people without having enormous ticket expense.
Yeah, it is true. It does spread the cost of the both the fixed and variable costs over fewer seats. I think one of the positives is that, you know, instead of 2 crew, we've got 1, and of course the training minimums can be a little bit lower. So this could be a feeder situation for people that want to be gaining more flight experience to then wind up on larger aircraft where they could potentially be making more money. But it's a good way to accumulate that experience. I think that it probably wouldn't be a bad thing if pilots made more money. You know, we talk about the struggle with not having enough pilots, which, you know, if they all made $1 million a year, do you think we'd have enough pilots? Yeah, we would. So I don't think we have a pilot shortage. I think we have a pay shortage. And if they start to make a little more money, it's going to draw more people out of the woodwork to do this for a living. I looked at it when I was younger. I was always interested in aviation, and I started figuring out what these guys made. I was like, are you kidding me? That is ridiculous. You know, they're making $20,000 a year and getting 4 hours of sleep a night. And I was like, I'm not, it just feels like it'd be killing myself for nothing. So I think if they made a little bit more money, it wouldn't be a bad thing. I still think that, you know, if you keep these aircraft moving, which I think you can by flying passengers during the day and cargo at night with quick change interiors, then I think you can spread the cost of the asset certainly over many more flight hours. And I think with efficient systems, you know, I think about like an Uber driver, those guys are just bouncing around all day long, as many hours as they want. And I think we could really keep these aircraft busy with some systems like, you know, Uber, Lyft apps, and then also being able to integrate cargo repositioning at night so that these aircraft are just constantly on the go and making money.
Well, those are great thoughts. Let me offer up another rope out of that tree, is the fact that as we try to automate, you make the task easier. So the pilot training is very much lower. And also the fact that we have, unlike the DARPA Grand Challenge and the ground problems of seeing a yield sign in Times Square by an unmanned vehicle, you've got the ability to build airspace that has all the right to curves and changes that automate easily. So my belief is that it'll be a blend of changing the task and of making the aircraft easier to fly. I am one of the developers that's, of course, give a number of the fly-by-wire systems, which are not fly-by-wire. They are advanced control laws that allow the machine to fly most of the task itself. It's so highly stable. And therefore, it could be that we don't need the skills the pilots would normally have. We need their judgment, not necessarily their control manipulation skill. Anyway, I really got a lot out of what you presented. I appreciate that. I did make a comment as part of the AIAA Committee on Certification. We decided to leave the bounds of just pure certification of air vehicles and talk about the infrastructure. What we find is that the market is probably a pyramid, and the bottom of the market, with all the great number of vehicles, has no people in it. That in fact the package express changes to the United States are probably going to create much more than half of the dollar revenue that goes into our future aviation system. We tend to concentrate on air taxi and people moving, which is great, but in point of fact, I don't know, let me offer up just an illustration. Amazon Prime has about the same dollar turnover as most U.S. airlines.
Wow.
I mean, and so what happens is once we have, further on this direction, 10,000 box trucks enter Manhattan Island every day to deliver packages, stuck in traffic, moving 8 miles an hour. And the people who want to get rid of the trucks, Amazon, have already committed to the fact that Bob Williams was sat next to me at the AIAA conference in Las Vegas and said that Amazon is planning on 500 million packages in the year 2029 delivered by AAM.
Wow.
So I
Wow.
think what you could look at this is you talked about the cream of the future AAM world, but in fact there's a more mundane world under there with prescription drugs and pizzas and all the package express things that can be delivered by small vehicles that are part of our air system.
That makes sense. And Nick, I don't know if it's me, but I'm catching a lot of static from your line, I think.
I wonder what that is. I had a problem with the internet. I apologize for that.
Try muting and I'll tell you if it's coming from
It's
your end.
Nick, because I can see his microphone moving up and
Okay.
down.
Okay.
Yeah.
Sorry, Nick.
Okay.
Try see if muting helps. So
Alright.
Yep.
I think that makes perfect sense. And I also, in thinking about, oh, there, the static's gone. So thank you. Yeah, I think night operations will keep these aircraft busy. And I also think that automation, as you said, is absolutely going to bring training requirements down, which will open up piloting to more people. And then I also think about the day when we're going to have cockpits that can either be flown by a human operator or completely automated or a little bit of both. And I think it's possible that we'll get to a comfort level where for passenger flights during the day, that will include a human pilot. But for moving cargo around at night, that might be once we've got a better comfort level and the FAA and insurers and consumers have the comfort level they need with automation, that might be something where those package only flights can be automated first before flights with people, potentially in the same type of aircraft.
And
Yeah,
for
so
listeners that were static, that's the U.S. Army model for the future Black Hawk.
Okay.
If you utilize 24 hours a day, about 8 of it with a person flying and the people in back, and the rest of it flying cargo, or as a trusted wingman for the manned machine. So it's exactly the model you described.
No kidding. Super cool.
Yeah, I think that's a really good point that Nick made, because the military use for eVTOLs would be remote piloted, and that will, I think, give that proof of concept that they're not subject to the same regulations that you would be for, domestic passenger flights, and rightfully so. Just as a sidebar, we did some economic analysis, including the cost of the pilot, insurance, fuel, all of this, comparing against helicopter flight, and looking at hourly costs. eVTOLs will drive the hourly costs down pretty dramatically, including the cost of the pilot. I think that the deeper issue, as you pointed out, is availability of pilots. But it can be a profitable service, even with the relatively small size of the eVTOLs today. If anybody's interested, you can reach out to me, and I'm happy to share some of the analysis. It's not really proprietary to Alakai, and my consulting gig there is up, so I'm happy to talk to anybody about kind of what our findings were.
And we're always looking for great presenters, Hugh.
Would be happy to pull some of the slides out and take the Alakai logo off.
Perfect. Perfect.
I just switched microphones. Is this quieter or less static?
Perfect.
Yeah,
No
louder.
static.
Good, good. A comment I'd like to make too, moving along in the same direction. One of the great shortfalls we have is the question of how we handle air traffic with regard to the number of eVTOL automated machines and manned machines, probably all clustered around urban environments. And it is my contention that detect and avoid is the largest single impediment to the growth of the system. If we demand that each vehicle have the necessary visionics on to clear itself of traffic everywhere, and also do that when a bug hits the screen, then we end up with a man-rated system put onto a prescription drug drone that'll never fly. $20,000-$30,000 worth of visionics to deliver prescription drugs is not going to happen. The contention I have is that, and some people are developing, and we've got some vendors where we have a network of all the vehicles reporting their position and their intentions, and they receive back in where everyone else is. That becomes the sensor. And if that network is high enough integrity, then it does give you detect and avoid, just not carried on the vehicle, but rather the network reports back to each vehicle where everyone else is, and we all work together on it.
Well, they're already doing a lot of that in aviation now. ADS-B, the aircraft get collision avoidance instructions that override air traffic control.
Exactly.
If TCAS tells you to climb and turn, you climb and turn, and then report. That's the rule.
That's right. And the point I'll make is that the guidance now is that all of the AAM machines have detect and avoid burden for air traffic safety, which is the right thing to do today, because we don't have this mythical system I'm describing. And so if I were the FAA, I'd say the same thing. Hey guys, you got to avoid it yourself. But sometime in the future, 15 years, we need to, I think, unburden remember I mentioned that pyramid. The smaller machines at the bottom of that pyramid can't afford to have the visionics for detect and avoid. And it would be fairly straightforward for us to come up with technical requirements for this network I'm describing, which becomes the sensor. And we give the same requirements. And I'll get off.
I think what Ben was saying is that I'll disagree a little bit here. Those systems already exist and they work very well. They'll get cheaper and they'll be more promulgated. Instead of reinventing the wheel, I think honestly working within the systems and the current systems that have been technologically developed and proven for very, very dense commercial traffic areas. I mean, I was a former fighter pilot. I flew off the coast of San Diego several times, and coming back into Miramar was an absolute disaster. I looked down at the display and there was more little dots on the radar than I could possibly ever even think to avoid. I even decluttered the display to the point where, again, there's hundreds and hundreds of small aircraft and large aircraft and commercial aircraft available and airborne in that area. The combination of commercial air traffic management, TCAS and other systems that are commercially available right now, honestly create a very safe environment. I would caution folks about trying to reinvent the wheel for sort of this revolutionary thing where there's going to be an order of magnitude increase in traffic. I don't think that's going to be the case. I think the way forward, personally, and I can be controversial when I speak, so feel free to disagree, is to work within the current systems and leverage current technologies. Because I think there is capacity there and well managed. I think we don't have to reinvent the wheel. Go ahead, Ben.
Yeah, no, I think, one of the things, it's hard to imagine it gets much cheaper now. If you go online, Sporties and those places, you can buy an ADS-B for your aircraft and, you pay more for a phone. You buy a high-end iPhone, you paid more than a collision avoidance system. But the other thing is you got to think back. Once we used to have LORAN, which wasn't a reliable, accurate system. But once we moved to GPS, I was a charter pilot during the time when we transitioned from air routes to point. And I can remember getting clearances point to point were rare. It was hard to talk air traffic control into giving you a point-to-point clearance because it was hard for them to manage those flights. But what they discovered by the time you got to the 2000s was it's actually way more efficient. The minute you start moving to point, you get rid of all these consolidation points where a whole bunch of airplanes have to cross a single nav aid over a fairly short period of time. And air traffic control has to sort them all out. If people are flying direct, and then they went to the post system for arrivals at major hubs, the 30 that you talked about, Andrew. So all the aircraft are pointed towards 4 arrival posts, and air traffic control just needs to sequence them into the posts, and everything else happens automatically. It's really clean. And so automating something like that is a lot easier than the old system.
Yeah.
which was very difficult.
Let me.
Yes.
I would pile
Looks
on
like
really,
Nick.
and Ben, I would pile on really quickly, and you may have seen this throughout your career as well as I have. It's the ancillary systems that have made the system a lot more efficient, right? So serious weather, for example, so I can see without radar on board, I can see the weather systems and I can start proactively planning my route around it, you know, a deviation around an impending storm system. Like we said, the TCAS systems and the more efficient routes, etc. I mean, those ancillary sort of I would say structural elements that have been improved over the years have made a much bigger difference than, you know, some revolutionary new technology. Okay, you know, GPS was a revolutionary new technology, but it is those structural improvements and the increase in efficiency in the overall system that has been dramatically interesting to observe. Anyway,
Yeah, I'll throw something in, and then Nick, go ahead, Nick. Sorry.
Yeah, just a comment because I really agree with both of you, Brandon. You're right. When I speak of it, it sounds like some sweeping magical change. In reality, if we could adapt ADS-B to have 5,000 aircraft tracked over the city of New York, we could do it, but it doesn't have the bandwidth. In the end, though, what you're using when you say ADS-B is exactly right. That's the model. It's just a question of whether in the future a system could be grafted into that contains all the elements you're describing. I don't think we want to necessarily talk about sweeping changes to all technologies, but rather just recognize that we're going to get away from detect and avoid and start to get to the point where that ADS-B type system is the way we detect. And with the integrity and the assurance that the FAA needs.
One of the friends of mine, a good friend of mine, does traffic like car traffic control systems. And one of the things that's really holding them up is the lack of distributed data centers. So for an autonomous vehicle to communicate with thousands of other autonomous vehicles to sequence through a traffic intersection, they have to have really, really short response times from the network. You know, they talk about delay. So you have to have all these remote data locations, like not at every intersection, but you can't have all your data from your car go all the way back to a centralized data center. Sure. Computation's accomplished, comes back. You need localized control, and aviation has not adopted that. But once you start to do that, once you say, well, each block of regional control airspace has its own mini data center that coordinates with the larger one, the centralized one, you start to be able to handle very high volumes of traffic. And remember, too, that in aviation, unlike cars, you can line everybody up from the time they take off.
Yeah.
You know, if you're talking to if you look at how trains work, where the speed of the train is controlled, you know, on the modern local systems, not Amtrak, but the more modern commuter systems, the minute the train leaves the station, the system recommends a speed. And the train tracks to that speed, so it doesn't have to stop between stations. It times itself out. And aviation would be able to do the same thing. And they're doing that in trains with pretty low bandwidth and really poor computing. So, you know, one can imagine aviation could handle the volume, but it is a structural change to support services.
Yeah. And I don't picture that we're going to introduce this kind of a system until we're a generation beyond where we are now in terms of all the necessary things like throughput and decryption so that vehicles can talk to each other and so on. However, if we don't think about it and start planning on it, we're not going to get there. So my belief is we should start fairly soon, and I do believe that the FAA has to approve it, has to agree to it, and has to have the hammer to come down on it if it doesn't meet the requirements. Because what we have today with the FAA is the folks who run the safest air traffic system on the planet, and they ought to be the ones who help to guide us to that other place.
Yeah, it's like AT&T. It's really hard to update a network. You know, it's one thing when you want a new modem in your house because you replace one. But when you're rolling out change across an entire network, it's expensive and difficult. And weird things happen as the FAA. And when I worked at HP, same problem. They changed out one server and the entire ordering system went down. So yeah, couldn't order an HP from HP for a couple hours.
But you know, if you look at where we are today, I offer it up to you. Look at your phone. Look at your household capabilities, and realize that every 20 years we shift entirely technology. We were VCR world 20 years ago. And anyone used a VCR in the last 5 years? So my point is,
Hey, I still have one.
yeah, I actually looked at a VCR tape a few months back. I thought, I actually looked at these things. My gosh. The point I'll make is that we just start planning this. We get the RTCA involved. The FAA runs the show. NASA provides technical guidance. We take the inputs like you just made, and we can then say, okay, 15 years from now, this is what we're going to do. And we just get it done. And I believe that it can be easily done if we simply plan it.
Andrew, put that on your to-do list, please.
On it. I got this.
I do
But
think
I do.
future
Go ahead.
system is going to be a transport system, and the money value of the system will drive it. I must tell you, when Amazon picks up the phone and says, I'm going to spend $250 billion, I'm going to receive $250 billion worth of revenue on this system, if you let me, and we all say, no, we're too busy right now. There are 777s landing at Kennedy. We can't think about a package express that's near the ILS there. They're going to call the senators they own, and we're going to discover a whole new way to run the business.
Well, FedEx now has a direct line to Memphis approach
Yeah,
because they want the aircraft they want to throttle back at 30,000 feet in an even profile, just like we were taught in flight school. If people went to flight school, right? You start your descent, you bring the power back in increments all the way down, and you never increase it. FedEx wants to do that all the way to the runway, and they don't like it when they have to level off or turn or do anything else. So they have people assigned to talk to Memphis approach to make sure that they tighten up the approaches and keep the FedEx planes arriving and fuel efficient as possible. And so there are models to do it. It's one of the things that I do think is interesting is the expansion of the model. Like the major carriers are required to have flight following operations.
right.
So they have to know not just who's on the plane, but where their planes are all the time. Not every second of every day, but they generally have to know where they are. When they're trans-Pacific and transatlantic, there are some flexes in there. But they follow those flights, and now they have maintenance updates. And I can remember a friend of mine working for United to tell me if something goes wrong with the plane and it's not flight operations directly related, the pilots might not know it. The plane tells maintenance, maintenance goes to the gate with the parts and the crew. When the plane taxis up, they're ready to go.
Yeah, we build helicopters too. You're right, Ben. Yep.
So there's no reason you can't do that. But the challenge is the aircraft. This is where Andrew was at before in his slides. The fundamental nature of the planes we're flying don't lend themselves. It's an add-on. You have to build the plane with the sensors. You got to build the plane with the thinking in advance. You got to build the plane with efficient propulsion systems. All that stuff has to be in the vehicle so that it can talk to the network effectively, and it has an ability to do what the network is asking. Yes, I'm sorry. Is that Brandon? Oh, I thought Brandon was going to add something.
Yeah, I'm going to toss
No, I was just sorry, I was adding in something in the comments, and I love where this conversation is. You guys, fantastic presentation, fantastic discussion. Ben, good job, Nick, fantastic points. My only point is I really just love to add in kind of an operational layer. You know, I hear this all the time, like the STOL aircraft. Okay, it can take off in 150 feet, for example, so it can operate out of a vertiport. Probably not the case, not to dump water on the situation, right? So 150 feet, takeoff, roll, accelerate, stop distance requirements, and all of the different operational requirements layered in above will require a significantly more distance. There's climb gradients. There's things that we consider in terms of departure corridors, and I think what's the standard vertiport? 12.5% gradient on a departure arrival corridor.
It's actually 8 degree. Yeah.
Okay, so anyway, it's above the, the 200 foot per nautical mile and some of the standard airport sort of departure and arrival corridors. But it's great to just elevate the conversation to include all of these different realistic operational requirements so that we can build a realistic future for how these things are going to operate, which I think is, I share the enthusiasm for everyone here. It's going to be an exciting future, but it requires some detailed thought.
And it works both ways. Once we have the criterion as to what the vertiport has and what the climb gradients are and what the obstruction clearances are, then the vehicles will follow to have that in their quiver of arrows, if you will. Some vehicles being able to climb out at steeper angles and work in urban areas, and others with better economics working in nice flat terrain from runways. And there'll be enough market for everyone to work that.
Well
I
put,
want
Nick.
to throw one more factoid because it's worthwhile. And
Finish this up.
FedEx carries 20.5 million packages a day in the weeks before Christmas, and they know
Yeah.
where every package is within 100 meters. Data is not the problem. It's whether we know what to do with it.
Well put.
Can I ask a quick question before we close out to is it Ken, the FAA gentleman that was on, and how if we were to look at pilot operated vehicles, we have a single pilot backed up by an operations center. Does the FAA view that? So one of the reasons they run two pilots is redundancy, right? So the first math was calculation, which is why there used to be four. You had a pilot, a co-pilot, a navigator, and a systems guy because the airplanes were hard to fly. We got it all the way down to two because the workload requirements. If we reduce the workload requirement, does the FAA have a position on redundancy, a remote redundancy?
What a great question.
It's a good question. I'm going to say that is going to be a very woolly issue to resolve right now.
Yeah.
Good thought. But yes, economics and automation have played a lot in getting to where we are. I think the future is really going to be determined by some other factors. So good question. I'm not sure I'm going to be able to untangle that one.
Translate what you said.
Yeah.
What you said is show me.
Yeah. I mean, the
You're
idea.
absolutely right.
The idea of having a small group of real deep experts sitting in a central location, able to help any aircraft anywhere in the network, just is incredibly appealing. The idea that I'm up there and I might not be as experienced if I'm running a 9-passenger aircraft, but the aircraft is constantly communicating. And if I have questions, I can alert the ground support guy and they can say, okay, yeah, you can make that approach. It's legal. Or no, you need to go to your alternative because we're looking at a bunch of parameters and you no longer meet them. It's it would be an amazing cost reduction driver for all the regional transport groups that can maintain continuous contact with their aircraft.
Within the context of aircraft that are essentially flying autonomously and can shoot and approach, land and stop on a runway better than any pilot can right now, as well, right? So it takes a bit of a leap of vision, but with the appropriate sort of infrastructure in place, and that requires layers of data and communications, safety, contingencies, etc. But it seems like that is a no-brainer for the future from my perspective. But
and it just got to certify
further out in the future though, Brandon, and I think what Nick said is show me, and it's going to be the show me is going to be the can you do it 100 out of 100 times? Can you do it 1,000 out of 1,000 times? And yes, there's going to be 1 in a million type capabilities that somebody's going to need to have. There's probably going to be a significant difference as to whether or not a human's on board versus is it just packages, or is it a drone outgrowth, UAS, AM. So
really,
it's an interesting conversation, and there will be a lot to be said.
Yeah, it'll be interesting to see.
I couldn't agree more. So thanks for your perspective on that. Really well.
Yeah, thank you. It's going to be hard because the FAA has to write all that certification rules. They're going to say, how is that ground operation certified? Who's in it? What are the distraction requirements? What are the communications links? Sorry, go ahead, Nick. I talked over you.
I don't think you did. It's a free for all. But I think what I would speak a little bit for Ken and say the integrity of the system is the biggest single factor, and the fact that when you take failures, that it keeps on marching, and especially when there are people at risk, and we all know that. But I'm going to tell you, we have a military that can run a cruise missile 1,000 miles and go. And this is a true story. The power station in Iraq that we bombed, it went right through the appropriate window and down the hall to blow up the control room so that it would kill them. It found the window and all that this is. So the real question is, can it do it 1,000,000 out of 1,000,000 times? That's the question. And we need to answer that before we get approval.
Yeah, when they did the Cat 3C approach for Denver's new DIA, they discovered a new problem. The damn thing was so precise, it actually led to an indentation in the runway because every single airplane was landing in a 2-foot section of the runway.
True story.
So they had to actually decrease the accuracy because they ended up calculating needed about 20 feet in order to prevent this indentation in the runway. But that amazed me. The first day that airport opened was a snowstorm. They ran 100 arrivals an hour on Cat 3C the first day they turned on the airport. They'd never been able to do that before.
Yeah, I did one of those in a helicopter once. It's fantastic. I'll offer this up, that we have to recognize that when we went to automated elevators, the safety of elevator systems in our cities went up by 2 orders of magnitude. When we had
Really?
Yes, I've got the data. And it was in the 1920s. It was typically that a major American city would lose 50 to 100 people a year in elevator accidents, and that was with manually sequenced doors, inner and outer doors, manually sequenced up and down. But with automated elevators now, the loss rate in the United States is below 100 for the whole country for 300 million people. So it tells you that automation, coupled with the simplicity of a system, and availability, is actually safer than having humans operate. 2 pilots is not safer than 1 pilot if they're both going to make the same judgmental mistake. And I hate to say it, but let's open our eyes. Anyway, we'll lots of work to go ahead of us.
Gentlemen, I hate to wind down a conversation like this because I feel like we're just getting going, but out of respect for everyone's time, we should probably wind things down. Thanks for great dialogue today. Let's keep it going. I love talking about regional air mobility. I love talking about AAM. We're always looking for speakers. So, when you're ready to present and have some topics of discussion you want to throw out there, I want to hear from you. Shoot me an email or find me on LinkedIn, and we'll get you some screen time and generate some more dialogue like this because I really enjoy it. Thanks everyone for being here today.
Great job, Andrew. Thank you.
Thanks, Andrew.
Thank you, Andrew.
Take care.
I can't seem to drop my presentation in here. Andrew, I'll send it to you and you can distribute, okay?
Happy to. Thank you.
Thank you, folks. Great.
Thank you.
I know.
Bye-bye.